All right, so let's go to the second page now. On the second page, we have 4 graphs and word problems associated with each one of these where they ask us to write the inequality for each one of these graphs. I have 3 steps written at the top of my page here. I'm going to ask you to pause the video and make sure that you write these down. They're not in your notes packet, and they're important. The reason why I like using this method, the 3 steps, is because it's pretty reliable, and it'll get us the correct inequality almost every time. The only notable exception is when we have a vertical line that acts as the border between the shaded area and the unshaded area. And we'll see that exception with number 5, the first example we look at here. All right, so those 3 steps are first you want to find the equation of the line. And I'm going to highlight slope-intercept form here. Unless GMM asks you for a different form of the equation, like it did on the previous examples that we looked at, where it asked for standard form, you're going to want to use the slope-intercept form. It's usually the easiest one to put the equation in when you have the y-intercept readily available. All right, so you're going to want to use slope-intercept form, find the equation of that line. The next thing you're going to look for is whether or not you have a solid or a dashed line, and that will tell you whether or not the points on your line will make the equation true or false. Excuse me, the inequality true or false. The third step here is to look at your shading. In the previous video, when we had the line that intersected the y-axis, we want to look at the shading right along the y-axis itself. All right, so if the shading is above the line on the y-axis, then we know that it's greater than relationship. And if it's below the line where it intersects with the y-axis, then we know it's a less than relationship. The only notable exception here is unless it's a vertical line. And again, that's the first example we're going to look at here. All right, so let's take a look at that now. It says this graph shows the number of tots and quecks that my friend Yoy might buy at the farmer's market. They want us to write an inequality showing the amount of tots and quecks that Yoy could buy. Well, this line here is a vertical line. We know that has an undefined slope, so we know that the equation of the line, it should just have an x in it. So x is equal to, and in this case, we see that it's going through the number 6 along the x-axis, right? So x is always equal to 6 in this case. All right, looks like we have a solid line, so all of our solutions on the line itself could be included in the solution set. All right, and then where is the shading? Well, we can't use the y-axis in this case to compare it to the line because the line itself doesn't actually cross the y-axis. So what we want to do is we want to compare it along the x-axis here. So the numbers, since they're less than 6, they're smaller than 6, that's going to be the way that that's going to be the relationship here, right? We're going to say less, all right? Less than. If it were on the other side, if it went the other way, if they were greater than on the x-axis, that's the relationship that we would look at when figuring out which inequality sign to use. All right, so we just need to replace the equal sign here with the correct inequality sign. So it's a solid line, which means that it could be equal to it, and it's less than, so x is less than or equal to 6. All right, very simple. But that is the one notable exception, okay? So you're going to have to remember that when you have an undefined slope, you're going to have to find the relationship for the shaded area compared to the line along your x-axis instead of your y-axis. The next problem here says this graph shows the number of yoys and alibers that my friend Frank might sell at the farmer's market. She needed to make at least $6. And again, they want us to write an inequality showing the amount of yoys and alibers that Frank could sell. So let's write the equation of our line here in slope-intercept form. B in this case, my y-intercept looks to be 3. All right, my slope, what do we have? Rise over run, right? So -3 divided by run, which is 2. Okay, so the equation for my line here is y is equal to -3/2 x plus 3. That's my first step. It looks like I have a solid line here, so I'm just going to write solid. So my possible points could be on the line itself. All right, and since I have a y in my equation of my line here, I can compare my values for my shaded area with the line on the y-axis. In this case, as we can see along the y-axis here, all the numbers greater than are shaded. All right, so I'm just going to write greater to remind myself that that's the relationship I should be thinking about here. All right, so I'm going to rewrite my equation on my line down here. I'm going to leave a blank for my inequality symbol here. And then we have a solid and a greater than relationship, right? So y is greater than, and it could also be equal to the values on the line. So y is greater than or equal to negative 3 halves x plus 3. That would be our inequality for this one. The next one, number 7, it says this graph shows the number of francs that my friend Boondin might have after x days. Again, I'm going to want to start with my equation of my line. So y is equal to mx plus b. My b in this case looks to be 1, positive 1. All right, my slope, what do I have here? 1, 2, 3, that's 4. So it goes up 4, and it goes right 1. Okay, so my slope is 4. So the equation of my line is y equals 4x plus 1. Okay, what kind of line do I have here? I have a solid line. And then the shading along my y-axis, it appears to be greater than the value where my line intersects with the y-axis, right? So I'm going to put solid and greater here. So when I rewrite this equation of a line to have my inequality symbol in it, all right, since we have that greater relationship and the line is solid, y is greater than or equal to 4x plus 1. The final example here, write the inequality showing the amount of NACSBIPs and learns that Boondin could buy. All right, let's write the equation for our line, y equals mx plus b. In this case, it's a horizontal line. That's one of our other exceptions. So we know it's going to be y is equal to a number. In this case, the number is 6 because it's going through two coordinates that have 6 for the y value. So y is equal to 6. Is it solid or dashed? It's a solid line again. So all of our examples had solid lines. And then when we're comparing the shading to the line itself along the y-axis, is it greater than or less than? In this case, it's less than, right? So I just need to replace the equal sign with my inequality sign. All right, it's less than or equal to in this case. So y is less than or equal to 6. Okay, so hopefully that makes sense. If you need to rewatch some segments to get all the notes, make sure you do that. Make sure you have those 3 steps written down. Like I said, it's a pretty reliable method. The only notable exception is when you have a vertical line to deal with for the shading. All right, thanks.